All right. This looks like an excellent crowd. This is exactly the group of people I was hoping. Oh, there's more people. I didn't want those people. Excellent. My name is Dr. Nick Williams. I am Australian, which normally is more meaningful when you're traveling the world. So I'll be more specific. I come from Brisbane, but I do want to introduce briefly who I am, and then we're going to talk about Buildpacks, which are super important, and I look forward to you hopefully learning something new, and more importantly, starting to use them in your organization. About 7 years ago, LinkedIn tells me that I started Stark and Wayne. We did Cloud Foundry, which has now become Kubernetes. Cloud Foundry runs on Kubernetes. Obviously, everyone here is excited about Kubernetes. And so basically American, European, we do a little bit over in Australia. Up in Brisbane, I've got excited by turning all my old Raspberry Pis into something useful. So if you go and meet the guys at Rancher, they have a thing called K3S, which is like it's full Kubernetes, but made into a really small footprint, both a disk and RAM. Really cool, and that picture is growing as I start to find all the other things I ever bought that sit in boxes, and becomes this cluster. And Angus Lee's put me onto this idea. The only thing missing from my picture is Lego. I want to add some Lego so then it will look cool and my children will think I'm hip. I'm going to introduce Cloud Foundry briefly, if only to introduce where Buildpacks come from and why I find them have solved so many problems in my life and our customers' lives over the last decade. Cloud Foundry is an open source platform, came out of VMware in 2011, and has been widely used. Fortune 500 companies around the world, and is the rock basis of the talk given by Zero on a product as a platform, or platform as a product, is really important to me personally. It's not the talk I'm going to give, but the idea of having a product owner who owns the outcome of an experience for all the developers is really valuable, and something we've taken to market with Cloud Foundry for the last half a decade. I really hope that as a Kubernetes community, we come to that understanding that it's not just toys, and look how these all actually work at all, that we want to own an experience for the rest of the organization. And one of the things that, to segue, that came out of that thing with Cloud Foundry was the build system of how we want to encourage developers to build things, which led to what we now have in the CNCF incubation as Cloud Native Buildpacks. So let's start with the problem, and then we'll come back to what is Buildpacks. All right. So every app over 10 years has this. This is not the last 10 years, but the next 10 years. You're building an app. The reason you built it, the real-world problems, they're going to change. You're going to change the programming language versions that you used, maybe even rewrite the whole thing in new languages. Obviously, the dependencies that your application uses, both language dependencies and OS dependencies, they're going to change. The base OS that you build on, whether it's CentOS, Red Hat, Ubuntu, pick another one, that will change. Maybe even you'll switch from one to the other because they become less important over time as Scratch containers. It may be the ultimate OS for most of us. How you do deployment will change. I know there are people still using Jenkins for good reasons. Many others have gone from no CI to some CI. You'll keep changing what is CI. Might be inside Kubernetes, might be outside Kubernetes. It will keep changing. And the entire group of people you work with will no longer work here. That's the next 10 years. And obviously, the CVEs are everywhere. And they get cool logos now. That's what's new. We always had CVEs. Now they have cool names and cool logos, which I think is perhaps the most endearing and valuable aspect of modern-day CVEs, is our awareness that you haven't rolled them out yet. You didn't know they existed, and you didn't know whether you'd done anything about them. And now you know there's a cool logo, and you have to roll them out. But how? So we want to separate these things out. And if we separate these things out in our organization, it makes it a lot easier for people to know that it's my responsibility to roll out that CVE and not the Node.js guy, which leads to the problem. So one way we might separate concerns is we'll leave the developer team and their product owner in charge of the real-world problem changes. Maybe we'd have a language-specific group, the Java group, figuring out what is the Java stack, the Spring stack, or the Ruby or the Go stack that we want to go to market with. You might separate that out as a concern or outsource it to another organization. And then the platform as a product. Curating that experience over a long period of time. Growing out your Kubernetes clusters, upgrading them, all the layers. Because we talk about Kubernetes as it's like answers all of these things, but it's not. It's a layer, and then we slap layer upon layer of other thing, and then we accidentally call that Kubernetes, and we just assume we can live with that. This is a super challenging problem, and a team's going to need to look after this. And so I really appreciate Zero sharing that story amongst all the other keynotes. Perhaps a more likely is the developer team will need to worry about programming language things. That makes sense. I mean, they chose libraries. They're probably going to be the ones that have to keep track of, do I upgrade a new version of Rails, a new version of Spring? That's going to be on their to-do list. And the rest of it, I think, is more likely. That idea of a platform team is super valuable, and as far as possible from the dev team. The dev team might have got you into a Kubernetes problem, but now it needs to be extracted away. And someone to own that, it should be their responsibility. But that still leaves us with the build aspect. So where are we at in 2019, Christmas? And where we're at is this thing. Now, you might have seen one of these, and no, I can't improve the font size. This is the Dockerfile. And if you can't read it at the back of the room, just close your eyes and imagine every horrendous Dockerfile you've ever read. This is the simplest one that attempts to build a Ruby application, which I pick in part because I kind of like Ruby, and B, you've never seen it before. Most people are not Ruby developers. But everyone's looks a bit like this. From Ubuntu. I don't know which one you used at the time that you built this image. This Dockerfile no longer tells me what's in production. It just tells me what might have been used when it was built, whenever that happened. Similarly, apt-get update and apt-get install Ruby really depends on what the first line meant. Depends on what you get next. Bit of a segue. Friends don't let friends install programming languages from package systems. You've got some good friends out there. Just guide them away to the light. Now, so you'll see a lot of Docker files where they'll build their programming language from source, and it'll be checksummed, and that's wonderfully awesome, and probably highlights more the problem of now whose responsibility is it? Congratulations, you've copied and pasted from Stack Overflow how to build Ruby from source. Who's going to find the instructions? Who's going to own and operate that over time? And then later on, there's the other things about Ruby gems and your programming language. I have a version of this that's specific. And the problem I have with this is that of separation of concerns. The problem I have is it seems more obviously this is the developer's problem, when all through this Dockerfile is an entire organization's set of problems. All these issues unfortunately meet in that Dockerfile. And I have a concern. So another version of the concern is, in my mind, this is what Docker Hub looks like. You go to Docker Hub, you can get your own artisanal Docker image. Sure, you got it, but you'd have no idea how to build it exactly the same ever again. And so what I think I've found is Docker was wonderful. Docker brought a whole new way of thinking about infrastructure, about deployment, about ownership, and it generated at least two problems. One was scheduling, which is what we're here. We're here to celebrate a solution to the Docker problem of how we get these containers running in places and everything layered on top of that. That solution, unfortunately, wasn't Docker's, and now Docker as a company did not benefit from much of what they sort of spawned. And I probably shouldn't laugh, it's sad. The other problem they created was the Dockerfile, with which I just introduced. And everyone here is excited about solving the first problem, and there's no conference for solving what do we do about Dockerfiles. I don't know that the problem's well understood. I don't think we've been around long enough to see that the plight of what it is to have 30,000 Docker images in production and Heartbleed comes out. Whose problem is that? How are you going to ensure that, how do you get back to your CIO and say it's done? Promise, it's done. We've updated everything, host machines, containers, images, etc. And how are you going to promise to do that for the next decade? And so Cloud Native Buildpacks is an incubator project inside the CNCF. It is one of the ways you might like to do it. I'm partly an academic, so I'm not really into selling the thing that's like, I'm going to tell you this is the only solution. I care a lot about you understanding the problem and being aware of it. I'd like you very much to try Cloud Native Buildpacks at the tool chain and to start to know that there are solutions, and then you can, as an organization, will figure out the path you want to take. Nothing's easy, but I do care about you being aware that this problem exists if unattended. There was a lot of content on the internet about Cloud Native Buildpacks. Fortunately, my voice is not the only one you're going to have to listen to. There is a lot of the people that work on Cloud Native Buildpacks, Heroku and Pivotal especially, have generated a lot of content. It's a lot there for you to learn after this. But I'll give you a bit of the rundown, and then I'm going to do some super demos. That's a tautology. All demos are super. Whether they work or don't work, just watching a demo is exciting. So I want to give you that thrill of live demos. So the gist of Buildpacks as a product, as a project, is three parts. One is the Buildpacks, which is kind of in the name. So a Buildpack is an isolated set of functionality that knows how to do something possibly to your application. So your application might be a Ruby application. It might be Java source code. It might be a precompiled Java jar file. It might be a Node app. It might be a composite of these things. The Buildpacks have the ability to decide, am I useful to this piece of this artifact, this code, or this executable, or binary, or jar file, or not? And how do I pair up with other Buildpacks to be useful? And then it will pick a set of those Buildpacks and apply them, and I'm going to show you some demos. So Buildpacks, there are like 20-something different organizations of generating their own Buildpacks. The Pivotal Cloud Foundry ecosystems building out a large set of them. This Cloud Native Buildpack is the future of Cloud Foundry and probably the future of the Pivotal VMware go-to-market around build systems. The next part is the builder. The builder is how do we put all this together, and what are the selection of Buildpacks we use in our organization. So you actually get to have a nuanced selection of Buildpacks that your company is going to use. It also means that all your Java applications can have a Buildpack that no one else is using. So this allows you to, across the board, make sure all the next versions of images that go out have some mutually agreed monitoring agent, security features, whatever, without having to go and find all those Docker images, those Docker files. And the lifecycle is the behavior that binds this all together. Our lifecycle is a set of libraries. I'm going to show you it wrapped up in a couple of tools, and you'll get the gist of what that is. And what we get in the end is still a Docker image, or what we start to refer to as an OCI, just to make it a little bit more vendor neutral. But it's pretty hard to say OCI without also wanting to say Docker image, just so we all agree what we're building. The benefit of the produced Docker image is that because we know how it got built, we know what we can do to it independently of who built it. You can't say that about a normal Dockerfile, because a Dockerfile might be from Ubuntu, but then it might do some crazy things that aren't what we call ABI compatible. And so you don't know that you can just replace the layers, which is something you can do, by the way. I should start with that. In a Docker image, it's layers, but they're not hard-coded. You can actually rewire them to point to new layers. So that means that if there's a new version of Ubuntu with a security patch, you can replace that layer, and your image now has a new base layer. The question is that a good idea for 30,000 images that you didn't personally build? If you know how they were built, then you have infinite confidence that you can, a lot more confidence that you can make that change. And we call it rebasing, and it's something that Heroku and Cloud Foundry organizations have been doing for almost a decade, before Docker. This idea of layers sitting on top of a base image and us being able to just replace that base image whenever we want without ever meeting the developers. We have been doing this for 7 or 8 years. So that idea is well tested, and what we're doing now is bringing that to Docker images. All right, and this is this idea of rebasing, where a new version of what we call the run image, which is the base image, comes out, and the platform operators have the ability to recreate every image with confidence. and rewire them at the registry level. So that's the features that operators get. They get build packs that they can curate and share with their entire organization. They get the ability to rebase images so that they can push out new secure versions of base operating systems. But now the rest of it, what I want to show you is the shiny things that developers get to use. And you can start to think how you might use these in your organization. So we're going to look at two things, and they both wrap up that life cycle. One is a CLI called Pack, and the other one is a running system that you can run on your Kubernetes, and it's called KPack, and it does this as a service for you. All right, so we're going to leave the slides. I put everything in the slides so that you can read the slides and remember the good times that we all had together. And if the demos go terribly, I can just come back to the slides and leave quickly at the end. So let's have a look at our app. You might never have seen a Node.js. They all look like this. They're about 4 lines long. It's production quality. It's good stuff. And we got ourselves some hello world. And so this is my app. You can see just to make sure that you know where I am. Nothing up my sleeves. Unrelated, if you're on Netflix, there is a new Magic for Humans, Season 2. God, I love that guy. Oh, he makes me believe in magic. This is just, he's wonderful. Anyway, back to not magic. So we have this Pack CLI, and it has some functions. The one that I have already run is set default builder. I mentioned before a builder is the collection of build packs. So I'm using one from the Cloud Foundry pivotal group of people. You're allowed to build your own builders, and they will ultimately make builders a more of a dynamic thing that just has happened automatically, but the interface is this builder, and the builder includes lots of build packs that my organization is happy to use and send out into production. So I've set a builder. And what else we got? We're now going to build. It's really that simple. I'm going to give it a name. So I've got the thing at the end is whatever, if you're using gcr.io, you do something like that. If you whatever it is that your image is going to be hosted on. So as we probably all know, without saying anything, it means the Docker.io or Docker Hub. A flag that's novel is the publish flag. The publish flag is not the same as Docker push. Literally, this is going to happen against the registry, which I don't think a lot of people know is a thing you can kind of do, that you can actually just interact with the registry. So I'm going to build this, and then I'm going to pull it back down as if it was never on my laptop to start with. So let's give this a go. You know what? I'm going to give it a tag because it's probably already cached. So we'll go forum 1. All right. And what we're going to see is the series of steps that make up the life cycle. And we're going to see it a number of times throughout till the end of the talk. So it went through and it looked at my code, and it automatically figured out that it is a Node/a Yarn application. And we'll get to the end and we'll go and have a look at what it did, so you can get a feel for how fast it is doing something for the first time. It's now exporting some cache layers, and now it's pushed my image up to Docker Hub or my registry, Docker registry, and we're done. Let's run this so we can feel good about ourselves. It is a Kubernetes conference, so we will also run on Kubernetes, so just hold your horses. Settle down. So impatient. So this is an example of even though I ran this on my laptop, the image is not yet on my laptop because it was published directly to the registry. Why would I do that? It's faster. And now we can curl, and there's our app. Okay, so we took our Node.js app and we turned it into a Docker image with all the beautiful attributes that I described on the slides of an operator can come along and rebase this every day or week that a new base OS comes out. What I wanted to show you was the layers, the stages. On the left, you can see These are the annotations of detector, restorer, analyzer, builder. These are the stages of the life cycle. And this is essentially the functionality of the Cloud Native Buildpack project. Now, what's not shown here is all the other build packs that were not used in the builder. And there are lots. There's like 12 different ones related to Java. And Java was a real winner here in this Cloud Native Buildpacks because there's a lot of different ways that people want to put together a Java app. What JDK? I mean, there's lots of different JDKs out there now, of versions of the Open JDK, for example. So there is it's detected that I'm using Yarn. If it didn't, it might have detected I was using a package.json file. And it would just produce the app slightly differently. You'll see nothing in there about an APM monitoring process, but I could have had those. I could have had my own company's additional build packs that I want to include, and that's what you're able to do if you want. And I would have got the benefit of that as a developer without ever knowing that you put that in the builder. So your interface as an organization, as a platform team, your interface is now the Cloud Native Buildpack builders. You put things into that, your developers automatically start shipping those features out in all their apps. They'll never even have to, you'll never have to talk to them. You get that relationship. All right. And then more layers. So I guess this is the most important part. Look, we actually downloaded Node. So we downloaded Node, set Node up. How do we do that? Who knows? Who cares? I don't care. Do you? You don't care. Unless you're from the Node core team and you're interested in what flags are set, you don't care. It's all open source. You can go and care all you like. But you didn't have to copy and paste something from Stack Overflow that you're now responsible for because you put it in your Dockerfile. So then we move on to the Yarn build pack, which means we look at the yarn.lock file, figure out what dependencies, download those dependencies, set up all that, and then we're good to go. It defines how this container will be started, which is all encoded inside the container. And super nice aspect is all this metadata of what's in this image, so close, is tagged in the metadata of the image itself. A little hard to read because it's JSON stringified as JSON inside JSON, but it means that you can go and look across all your images and find out what's in them. Is there a bad version of Node.js in a version of all your images? You can now look. And that's a really valuable thing from an auditing perspective. All right, what's next? What's next is we will run this on Kubernetes because we're at a Kubernetes forum, and I think it would be pretty sneaky of me to walk away and never have them run anything on Kubernetes, and I won't do that to you. So let's, what do we want to do? We will watch kubectl get pod, service. Let's start there. There's obviously nothing going on. Interesting. Oh, there's that default one. All right. Kubectl run, go to our image. What was our image called? Oh, there it is. I'm not going to type kubectl anymore. I hope everyone's alias to K. If you're still typing kubectl, cut that out, all right? Go and find yourself a set of good aliases, get auto-completions, your life will be better. You'll thank me and everyone else that ever uses it. All right, we're going to run this image. Give it a name. We'll call it forum. And we'll call it sample because that's what I call all my other demos. And then we'll run that. That will create a deployment. A deployment will create replica sets. Replica sets will create pods, and the pods will appear because Kubernetes is awesome. None of this has got anything to do with build packs. This is just me making sure that you like Kubernetes. And I'd hate you to get to the end of the day and no one actually ran any commands in real life. That would be really sad if you're a new person and you came back from the forum and it's like, I never saw anyone use Kubernetes. It was the weirdest day ever. So you can tick that box. You actually saw someone use the goddamn thing. So here we have our pod. We don't have a service yet. We can expose our deployment. I'm not advocating typing these commands versus using YAML files, but it does demo better. Expose deployment sample. I cannot remember. Oh, now I want to, in the stress of being on stage, your brain stops remembering things. I can't remember that. So I know that the pod is looking to listen on port 8080. That's just a standard that the Buildpacks assume that 8080 will be the incoming port. I'm going to expose that on a public IP address, port 80, because that's cool. And now we wait patiently for, in this case, I'm on Google GKE, so I'm on Google Computer. I'm just waiting for them to give me a load balancer. And what I've discovered is it takes longer depending on how many people are watching. So it was pretty quick when I was in my hotel room this morning. It'll take about half an hour because you're all watching. So if you all just look at the back of the room, it'll happen a lot quicker. And there we go. So let's add this to our progressive. Oops. All right. There we go, hello world. Now, you might have forgotten how we got here and not appreciate the awesomeness. So we'll do something that no one would ever do live in front of other people, and that's make a code change. And watch me type. That's pretty cool. I'm such a good typist. All righty, we'll do this again. Of note, as we watch this happen, is that whilst in Cloud Foundry and Heroku, the build and the deploy are coupled. So if I do a CF push, it will go through this staging process. We call it staging, or the Buildpack process. It will also know that I've implicitly given it permission to push that app out. In this pack command, we don't implicitly have that relationship. It will produce a Docker image on my registry, and for which I will be happy. It is my subsequent responsibility to decide if and when and where that should now go off somewhere. And I will do that using the kubectl commands. You might do it using some other CI system that you've got. Because you might take that Docker image and first test it locally, perhaps bundle some tests inside it, and then perhaps send it off to a staging Kubernetes, and then through a pipeline. But what we get is this immutable URI of what it is. So now let's kubectl set image. There we go. I'm just going to leave that there so I can remember what I'm typing, because this, okie dokie. And now we can see, because we're watching, we updated the deployment. The deployment creates a new replica set. The replica set says, well, I've got no pods. I need pods. It goes off and creates pods. Then it gets rid of the old replica set. That means it doesn't need those old pods. And what we see is pods coming and going. And we now see that our app has been rolled out. So Buildpacks helped us make the image without ever making a Dockerfile, without ever worrying about how we do Node and what's the right way. How do we do it in our company? Right? And you ask that question enough, every team that asks, how do we do Java here, means you've got another bespoke Dockerfile. Because at best, you're going to copy what some other team's done at that moment in time, and now everyone's organization forks and wanders off and creates new Dockerfiles. There's no way that they're all going to end up looking the same. So we get this additional benefit that we're always going to be going through the same build cycle, and that we know every image that was just created went off the same builder. All right. We did that. It was awesome. There's a Java one. You get the gist of, like, there is, on a very simple Java app, it pulls in 5, 6, 7, well, actually it says 7 out of 14 build packs. There are 14 Java build packs, and it used 7 of them. And you can give it clues as to what you want, but for Java people, it's just super valuable. Perhaps less valuable for some of the other ecosystems where we have a different build chain, and perhaps we're already building Go apps and just stuffing them into Scratch containers. But if you've got a Java Spring organization, this stuff is super valuable. I mean, a lot of this comes from the organization that makes Spring. So they care a lot about the Spring experience. We went through this demonstration of deploying our pods and exposing them as a service, and then we updated it, and the crowd went absolutely bananas. We looked at how it was a node, picked the web process. If it was a package.js lock file, then it would have used npm in a different build pack. All right, to finish off, we're going to introduce another tool that you might know. You're running Kubernetes because you're champions. And the Pack CLI is more for developers running locally. I think a conversation many organizations are having is, what should we let developers do and what should we take off them and give to robots? Robots is code for CI/CD, but I think they're cooler if you call them robots. K-Pack is sort of part of the robot era. Pack is like letting humans do things and feel valuable. We can't let our humans feel too valuable, so let's let robots do things. So K-Pack is that process, that lifecycle process, as a service and running on Kubernetes. And as it goes to follow through the slides, as a Kubernetes thing, its primary experience is we are going to create some resource instances of custom resource definitions, and it will then have a controller, it will do all the work. I'm going to show you the work, and we're not going to get too much into the, how to write operators and things. So I'm going to expand this now to, I want to look at a thing called an image. I've already installed K-Pack. It's really simple. You set up some credentials for your registries and for your Git repository. You install the operator, it's a Helm chart, and what else? Some builders, and that was it. And so now and I'm going to show you what one looks like. You know what? That looks a little ugly. Let's make it colorful. And there it is. So this is invisible on my black screen. Let's not do that. Let's put it on a white screen. That's much better. So we're saying, hey, there's a builder I want to use, which has got my Buildpacks in it. I might have multiple builders in my organization. But this one, I know it knows how to do Node.js apps. I wish to have a disk for caching so that my builds get faster over time and stops downloading Node every time. Node is kind of small. OpenJDK is kind of large. And caching starts to really kick in. And what I'd like it to do is to continuously watch my Git repo. So every now and then there's a new commit on that branch, fire off a build. All that's going to happen is it's going to build Docker images. It's then up to you to decide whether you wish them to go into production or not. All right. Let's do this. KAF is kubectl apply minus F. Because by now, I told you earlier to install all your aliases, so I assume you're up to speed on those aliases. All right, I assume you can all do two things at once. Now, down here, we have our image. So we've created that image. That's what I just manually did. And what it did is it started a new pod that's doing the build. And you can see that it's primarily made up of init containers. Let's find out what it's up to. There is a little CLI we get for free that we can install. And so what this CLI is doing is pretty much watching the output of those init containers. What's in the init containers? Each stage of the life cycle of Cloud Native Buildpacks. They just sort of do them one after each other, just borrowing the concept of init containers to do a sequential series of steps. It does exactly what we did before, except it spat out a tagged Docker image. And you don't have to run it locally, you just commit and off it goes. So now you would have a second system that watched for these, but we will do it here manually. Let's do set image. Oops, I copy and pasted too much. It will go back to whatever it was before. We haven't committed anything. So the next thing it will be go back to Hello World, because that was what was on the Git. So since you don't trust me, because I'm an untrustworthy character from Brisbane, we'll do one final test. What are we out there? Showground. Haven't seen a pig yet. Dun, 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 dun. All right, we push that, and off it will go. I'll add one more instance or resource to our little thing so we can watch. So the way it works, the way K-Pack works, is it's watching my Git repo because the image tells it to. And when it finds a new commit, it first creates a new build instance. So that's what we're waiting for now, is for it to do that polling or whatever. I assume it's polling. I didn't set up a webhook, so it's definitely polling. It will create a new build. The build will create a pod. The pod will build our thing, upload it, and it's going to be awesome. And obviously, I'm talking because we're waiting. Because you're all watching. We talked about this. Demos don't work when people watch. Come on! So impatient. Pretty sure we're over time. So, it's doing something. It's pretty exciting. There it is. So there's our new build, and it will spit out the new image, and we'll run it. For a finale, we'll run it. Let's just make sure I've covered everything. Interesting, KPack as a thing, the way they make the base images that they use to run KPack on my cluster is built using the pack CLI. I thought that was wonderfully dog fooding. So 5 points to them for eating dog food. That's not the phrase. You don't actually eat dog food, for anyone that's new to that. So I highly recommend you start to play with this. They have their own Slack channel. What are we up to? Do I have a slide? Yeah. So they have a Slack channel, buildpacks.slack.com, and they're just great. Yes, a lot of them are based out of the US, but very responsive to questions, and a super great community from multiple different organizations. And so this becomes our possible universe where the app team can focus on their universe and be blissfully ignorant of much of what goes on, both in terms of how it gets built and how it gets run, which I think is what we all wish for when we go beyond just playing with it ourselves. And the platform team now has confidence that they can roll out changes because you've got this contract of knowing how things get built that allows you as a platform team to be able to go off and do your job. We need to just try to encourage people to not go straight to Docker files the moment something doesn't work. And maybe you have to go forward and find all the teams using Docker files and encourage them to migrate away. Let's finish with the grand finale of seeing our app roll out. So we've got our new pod. We get the new image from here. We set image. I mean, Kubernetes is cool, right? There's that extra thing that I didn't need. Where does that go? It goes there. Creating a new pod. It will roll out, and hello, showgrounds, which I've now can see I've written the word grounds twice, so you know it's a live demo. Who would have done that if they meant to? No one. So thank you very much, everyone.